and welcome to this exciting PLC Goods video tutorial series led by yours truly, Syed Reza Fattahzadeh, an industry experienced and education lover with over 20 years of hands-on experience in the dynamic world of industrial automation. In this video, I am excited to introduce you to a powerhouse of knowledge, our Allen-Bradley PLC programming course using RSLogix 500 and 5000 software. Our course is a complete journey made up of a stunning array of 32 video lessons that will involve you deeply for a grand total of 9 exciting hours. Throughout this adventure, you will uncover the art of mastering the details of programming the famous Allen-Bradley PLC 500 or ControlLogix processors. We will explore the domains of RSLogix 500 and the boundaries of ControlLogix and CompactLogix Allen-Bradley PLCs using RSLogix 5000. You won't just be an observer. You will be actively participating using related simulators or even your very own real PLC trainers. Each step is carefully recorded, ensuring your journey is trouble-free and easy as we explain fundamental tools such as RSLogix 500 or 5000, related simulators, and factory I/O software, making it the simplest course to become a skilled PLC programmer, even if you don't have a physical PLC available to you. So welcome joining us, and thank you for choosing to begin on this amazing learning adventure with us. Let's not wait any longer and start lesson number 1 right away. In the video lesson number 1, the following topics are covered: introduction to PLC hardware and its wiring, explanation of the industrial automation pyramid and the function of PLCs or programmable logic controllers in automation, introduction to the Allen-Bradley MicroLogix 1500 PLC, showing the hardware and connections of the PLC, creating a simple industrial circuit using EKTS software and simulating it, wiring a switch and a lamp to the PLC, writing and transferring a program to the PLC using RSLogix 500, establishing communication between the computer and the PLC using RSLinks, showing how to download and run the program on the PLC. A practical example of how a PLC controls a lamp based on a program. The content also highlights that learning to program one brand of PLC can enable programming other brands as well. The video provides detailed overview of PLC hardware, software, and their integration in industrial automation. In video lesson number 2, I discuss PLC ideas, including scan cycles, data types, and addressing. I showed the creation of a simple industrial circuit using a PLC, explaining how the PLC processes inputs and controls outputs. The video covers topics such as how a PLC processes input and output data in an ongoing cycle an explanation of how PLCs store data, including bits, bytes, and words, how to address digital inputs and outputs within a PLC program, creating a simple industrial circuit with a PLC and understanding the power and control circuits, presenting programming in RSLogix 500 to control an electrical motor using digital inputs and outputs, downloading the program to a PLC and testing it. The video concludes by showing how a project has been successfully tested. In video lesson number 3, the following topics are covered. Testing a PLC program without a physical PLC using RSLogix Emulate 500, showing the use of normally open and closed contacts in PLC programming, explaining how the state of these contacts affects the behavior of connected output field devices, showing how to monitor the state of digital inputs and outputs in different ways, including using LEDs on the processor panel, checking connected devices, and utilizing input-output image tables. This video lesson offers a practical showcase of PLC ideas and provides insights into testing and monitoring PLC programs. Lesson number 4 covers several topics related to PLC programming as following. It shows how to use latch and unlatch instructions in PLC programming. The video explains how to use one-shot rising and falling instructions, which produce a single pulse when their input condition changes. Basic logic functions like AND, OR, and XOR are briefly introduced, showing how to use them in a PLC program. A simple project is presented involving 3 conveyors connected in series. This tutorial provides hands-on examples and practical applications of PLC programming ideas. The video lesson number 5 concentrates on timer instructions. The tutorial explains the 3 most common types of timers used in PLC programming: timer on delay, timer off delay, and retentive timer on delay. The video also includes a simple project showing the use of on delay and off delay timers. A flasher lamp is created using a on delay timer where the timer is continuously activated to create a flashing effect on an output. The video shows how to test the program using RSLogix Emulate 500, simulating the process with input image table monitoring. The tutorial offers practical examples to help viewers understand and apply timer instructions in their PLC projects. Video lesson number 6 introduces up and down counters in PLC programming for event counting, explaining how these counters increment or decrement their values based on specific input conditions. It covers fundamental ideas, including overflow and underflow conditions when counters exceed their upper or lower limits. The video presents a practical parking lot project where an up counter monitors incoming cars and a down counter adds up departing ones. Green and red lights indicate parking lot residents. Overall, the tutorial provides a clear understanding of up and down counters, real-world applications. In lesson number 7, we examine the comparison instructions. The video introduces integer and float data files, addressing how these data types are used to store numerical values in PLC memory. The tutorial explains necessary comparison instructions including equal, not equal, less than, greater than, less than or equal, and greater than or equal. A practical display showcases the use of the greater than instruction comparing two values and activating a digital output based on the comparison result. Furthermore, the limit instruction allows you to establish both low and high limits for a third integer number, and it shows its usage by a simple test program. The video also amplifies a parking lot project from a previous tutorial, using these new instructions to control the entry gate based on parking lot occupancy and sensor activation. In video lesson number 8, I examine mathematical instructions in PLC programming, categorizing them into basic functions and number system conversion. In the basic functions category, I cover essential operations like addition, subtraction, multiplication, division, square root, and negation. I introduce number system conversion instructions focusing on the TOD instruction, which converts binary numbers to binary coded decimal form. I explain BCD as a method of separating decimal digits for display, making it especially useful for 7-segment LED displays. The tutorial extends an earlier parking lot project by adding extra up counters for multiple entry gates, encouraging viewers to do the project by themselves. Additionally, I present a temperature conversion project showing how to convert Celsius to Fahrenheit using mathematical instructions like multiplication, division, and addition. The conversion result is then transformed into BCD format for display on a 7-segment LED. In video lesson number 9, the shift and sequencer instructions in PLC programming are explained. The bit shift right and bit shift left instructions are introduced. BSR shifts bits to the right and allows you to copy a specific bit's state. The FFL and FFU instructions are also showed, where FFL loads data into a stack memory and FFU unloads it. The video shows practical examples of these instructions with a highlight on addressing control files and parameters. The lesson provides a clear understanding of each instruction's purpose and operation. The lesson number 9 serves as a foundation for viewers to understand the ideas of bit and world shift instruction, preparing them for the next video on sequencer instructions and a practical project presentation in PLC programming. The video lesson number 10 provides practical insights into working with sequencer instructions, making it a valuable resource for those learning PLC programming and automation control. I introduced the idea by showing a practical project that involves controlling traffic lights at an intersection. The video covers the operation of sequential output instructions, highlighting the use of a mask word to control specific bits and leave others available for different functions. Viewers are also introduced to other types of sequential instructions, including sequencer compare and sequencer load, with explanation of how these instructions work in relation to sequential output instruction. Lesson number 11 offers a comprehensive overview of PLC programming using RSLogix 500, partitioning the content into clear key parts. The tutorial begins with a true explanation of the move or MVM instruction, showing its use to transfer values from a source to a destination address. The video also covers bitwise logical instructions. Next, the tutorial introduces program control instructions. These include jump to label, label, jump to subroutine, return from subroutine, and subroutine label instructions for creating and calling subroutines. The video transitions to working with analog signals, highlighting the need for 16-bit words to process analog data in PLC programs. It explains how to convert numbers into related voltage levels using a real-world example with a level transmitter's voltage signal. A practical project is developed to read a voltage signal using an analog input module. The program calculates the actual voltage and controls two lamps based on predefined voltage thresholds using mathematical instructions for conversion and comparison. This tutorial equips viewers with a strong understanding of PLC programming using RSLogix 500, covering essential ideas, instructions, and practical applications. The tutorial number 12 highlights the importance of configuring virtual controllers and input-output modules and shows how to use RSLogix 5000 to write a program and integrate the input-output addresses. It also shows the process of compiling the program, establishing communication with the virtual processor, and running the program. I start by comparing RSLogix 5000 to RSLogix 500 and highlighting that RSLogix 5000 is designed for configuring and programming the ControlLogix 5000 family of controllers. The key focus is on a practical project that uses a push button to control a lamp. The showcase covers elements such as ladder logic, digital inputs and outputs, and connecting the virtual PLC to the software. The step-by-step approach, clear explanation, and hands-on display make it priceless resource for those starting with Allen-Bradley PLCs 5000 controllers and software. Lesson number 13 provides a comprehensive introduction to PLCs and displays how to connect to a PLC using RSLogix 5000 using the serial port and an Ethernet module. It outlines the differences between compact and modular PLCs, highlighting their applications and cost considerations. The video showcases the hardware setup, including the PLC chassis, power supply, communication module, CPU module, and various input-output modules with detailed explanation for each component. It guides viewer through configuring serial connections and uploading project data from the PLC to the computer. Additionally, it displays how to establish an Ethernet connection with the PLC using an Ethernet module, adjusting IP settings, and uploading project data. The tutorial highlights the use of simulation software for future program testing. This video is a valuable resource for those learning PLCs and RSLogix 5000 programming. In video number 14, we will take a closer look at Logix 5000 controllers. We focus on configuring PLC hardware in RSLogix 5000. I provide useful tips along the way. I introduce my ControlLogix 5562 controller and chassis configuration, detailing modules and their revisions. For new users, I will explain the importance of matching revisions. I configure different modules, including analog, digital input-output, and Ethernet module, walking you through each step. I simulate a simple industrial circuit using EKTS software with normally closed and open push buttons and a relay controlling a three-phase motor. I relate that to PLC control, where we can get similar functionality without rewiring by changing the program. We write a basic program in RSLogix 5000 using module addresses and then compile and download it to the PLC. I show the logic, including how digital inputs trigger a relay to control a load. In lesson number 15, I introduce a tutorial on using Factory I/O software to simulate industrial processes. The content includes setting up connections, creating a simple project in Factory I/O, connecting it to a PLC, and modifying the PLC program to control a belt conveyor. The tutorial also covers connecting Factory I/O to the PLC using Ethernet and explains the use of tags in Factory I/O. It brings out the importance of understanding how contacts and push buttons affect a PLC program. The lesson number 16 introduces a tutorial about FactoryTalk software, which is used for visualizing industrial processes. The video begins by showing a simple traffic light project using RSLogix 5000, covering the creation of a program that controls the lights, timers, and conditions. The video also highlights the importance of programming based on outputs rather than conditions and offers an example program that controls the traffic lights effectively. The video features the role of HMI screens in industrial processes. In lesson number 17, the content focuses on introducing FactoryTalk software and showcasing how to design an HMI screen using the software for monitoring and controlling an industrial process, specifically a traffic light project created in the previous video. The video covers various points, including modifying the PLC program, creating tags for the HMI screen, connecting HMI to the virtual PLC station, and designing the screen with images and objects. The lesson also highlights the practical applications of HMI screens in industrial settings. In lesson number 18, we examine bit logic instructions with RSLogix 5000 and kick off a project using Factory I/O. We will cover the main points, previous lessons covering RSLogix 500 and RSLogix Emulate 5000 for programming Allen-Bradley controllers, and introduce Factory I/O for industrial process simulation. Shifting towards a PLC trainer controller and Factory I/O, we explore bit instructions like examine on, examine off, output energize, latch, unlatch, and one shot. The main project involves sorting boxes by height with components such as a conveyor belt, control box, and pusher. To do the project, after configuring factory I/O and connecting it to the controller, we will conduct testing with real and virtual push buttons and sensors. In tutorial lesson number 19, we focus on timer instructions including timer on delay, timer off delay, retentive timer on, and the reset instruction. These timers are important when actions need to take place after a specific time. I covered the process of creating timer tags, setting presets, and managing gathered values and how to use these in programming. I explained the functionality of an on-delay timer where the output action happens after the preset time once the timer conditions are met. We examine how to configure and use on-delay timers effectively. Additionally, we explore off-delay timers that act as opposed to on-delay timers and retentive timer on delay, which maintains the timer's last time value even when disabled. I introduced the reset instruction for timer and counter resets. Moving to a practical project, we enhanced the box sorting system from the previous video using timer instructions. We programmed the system to initiate an alarm siren for 5 seconds upon a start, followed by activating the conveyor and a warning light. We also resolved a bug in the program using the one-shot fouling instruction to delay the stoppage correctly. This video provides valuable insights into timer instructions, their application in PLC programming, and how they improve a sorting system. In lesson number 20, we explore counter instructions in PLC programming, which include count up, count down, and reset. Counters differ from timers as they accumulate state changes in an external trigger signal. We learn the fundamental ideas of counters and their functionality. We examine creating and using countdown counters, explaining parameters such as preset and accumulated values. Additionally, we discuss the overflow and underflow bits, which indicate upper and lower crossing the limit. The video showcases how an up counter increments based on a Boolean transition while a down counter decrements. We complete a program to test a down counter, including a digital input and a reset mechanism. This tutorial offers a comprehensive understanding of counter instructions, their applications, and practical usage in a sorting project. Lesson number 21 is focusing on math instructions in RSLogix 5000. These instructions are categorized into basic math, advanced math, trigonometric functions, math conversions, and compare instructions. The video highlights utilizing RSLogix 5000's help window to understand these instructions effectively. The tutorial previews an upcoming project in which these math instructions will be put to practical use in a water tank system. We also set up a virtual processor, establish connections, and configure a virtual PLC station for this purpose. The tutorial covers basic math instructions, showcases the importance of data type, and highlights a practical presentation of division instructions. The compute instruction is examined along with advanced math operands. Trigonometric functions, conversion, and compare instructions are explained with practical use cases. This video offers a comprehensive overview preparing viewers for real-world PLC programming applications. In PLC tutorial video number 22, we explore the practical application of math instructions within Allen-Logix 5000 to control a tank system using factory I/O. This system includes two valves, regulating water levels through a 0 to 10 volt voltage range, monitored by a level meter that provides feedback between 0 and 10 volts related to water levels up to 300 centimeters. The tutorial covers the design process in factory I/O, program folder creation, and tag definition. It highlights three program folders: desired level for voltage conversion from a potentiometer to water levels, another for converting the level meter signal to current water levels, and the main routine is the main program folder executing tank control logic based on a start-stop request and water level comparisons. After explaining the project's structure, the video concludes by addressing verification and program property issues and highlights the importance of a shared tags for communication between factory I/O and the PLC. This tutorial sets the foundation for understanding PLC programming and implementing real-world control systems. In tutorial video number 23, we examine the move logical group of instructions. The video begins by introducing the move and masked move instructions, explaining how they copy values from a source to a destination, highlighting how the mask move instruction allows specific bit selections. Following this, the tutorial explores logical bitwise instructions, including bitwise AND, bitwise inclusive OR, bitwise exclusive OR, and bitwise NOT. Each logic operation is revealed through practical examples showing the behavior of these operations with binary values. The video also introduces the swap byte instruction, which rearranges the order of bytes in a value along with the clear instructions used to reset all bits within a destination address. Finally, the bit field distribute instruction is explained, illustrating how it can copy mentioned bits from a source value, shift them to a desired position, and write them to a destination address. This knowledge sets the foundation for a practical project where these instructions are used to control 8 fans in industrial cabinets based on a combination of limit switches, temperature sensors, and push buttons. In tutorial video number 24, the input-output instructions in Allen-Logix 5000 are explored. The video shows the importance of these instructions in industrial processes and the need for connecting multiple controllers without rewiring equipment. It shows setting up 2 virtual controllers in a virtual chassis, simulating communication between them through iOS links. The first focus is on the message instructions, which enables out-of-sync data exchange between controllers. Configuration details, message types, source and destination tags, and their application in the second controller's programs are explained. The video also introduces get system value and set system value instructions for accessing and modifying system data. It showcases GSV in action to recover the controller's scan cycle time. Finally, the immediate output instruction is discussed, highlighting the importance of improving scan cycle times for regular PLC operation. In tutorial lesson number 25, the focus is on enhancing a two-intersection traffic light project using input-output instructions. I connect to a virtual PLC station using RS links, configuring the virtual hardware with ControlLogix 5000 and detailing the traffic light program design and HMI screen setup created with factory TalkView Studio software. The goal is to coordinate the second intersection's traffic light with the first, accounting for a 10-second delay. The video covers controller state detection with the GSV instruction and data preparation for exchange between controllers using message instruction. Two subroutines for normal and fault conditions are created with different control logic based on the first controller's mode. In video tutorial lesson number 26, we examine the alarm group of instructions, focusing on both digital and analog alarms while working on a water tank control project. The tutorial starts with hardware configuration in ControlLogix 5000 and introduces the digital alarm and analog alarm instructions, centering on the latter. To show the analog alarm instructions functionality, a water tank system is created in Factory I/O featuring filling and discharging valves, a water level meter, and control interfaces with potentiometers. The tutorial guides you through setting up the necessary tags in ControlLogix 5000 to match with Factory I/O equipment. ControlLogix involves using move instructions to control the valves based on potentiometer inputs. The tutorial introduces alias tags for improved program readability. It then configures the analog alarm instruction to monitor the water level, complete with custom alarm limits and properties. You will learn about acknowledgement, class assignment, and rate of change. The video illustrates working with alarm conditions and showcases the interaction between the water level and alarms. You will see the alarm properties window in action for tracking and acknowledging alarm events. A comprehensive system test shows the alarm conditions practical application. The tutorial concludes by summarizing the analog alarm instructions, operation, and suggestions at its similarity to the digital alarm instruction. Video tutorial lesson number 27 covers various aspects of PLC programming, data types, arrays, and the file MISC group of instructions. It discusses various data types, including Boolean, integer, double integer, and real, as well as other types like timer, message, and alarm. The tutorial then concentrates on arrays, explaining how they allow you to store a group of data of the same data type using one or more dimensions. It provides examples of creating and working with arrays. Next, the video examines the file MISC group of instructions, especially the FAL or file arithmetic and logic instruction, which can perform copy, arithmetic, logic, and function operations on data stored in an array. A practical program example is displayed using the FAL instruction. The tutorial concludes by monitoring that the file, shift, and sequencer groups of instructions work with arrays as well. In video tutorial lesson number 28, we explore the FFL and FFU instructions for a warehouse project. After reviewing array tags and related instructions, we examine these fundamental commands using the help window. FFL adds data to a stack, while FFU unloads the first entry and shifts the stack in an array. The project centers on a stacker crane managing 54 storage positions across 3 racks. We control the crane manually with 4 digital inputs, moving it up, down, and horizontally to position boxes. This numerical mode accepts integers from 1 to 54 for defining storage slots, utilizing an array in PLC memory. Factory I/O duplicates the project, showing the setup and connecting inputs and outputs for the PLC program. This tutorial ensures a practical grasp of FFL and FFU instructions within a warehousing framework. The video tutorial lesson number 29 covers key instructions such as jump, label, and no operation, explaining how they affect program execution. Subroutine instruction, including JSR, show how to create reusable program segments. Other instructions like TND, MCR, and interrupt commands are briefly discussed. The fundamental AFI instruction is highlighted for controlling program flow. Practical examples are used to display ideas. One such example involves calculating the coefficient of variation for various data sets using subroutines, showcasing their reusability. The tutorial also introduces event-driven tasks with the event instruction and outlines task types like continuous and periodic. The video tutorial lesson number 30 is on the Sequential Function Chart programming language. This tutorial covers an overview of the 3 fundamental PLC programming languages: ladder diagram, function block diagram, and structured text before studying SFC programming. SFC is a graphical language that allows you to control sequential processes by defining steps, transition conditions, and actions. The tutorial shows how to create a simple SFC program with 3 steps and their associated transition conditions. Additionally, it explains 3 SFC-related instructions in the program control group: reset SFC, SFC pause, and EOT or end of transition. The tutorial concludes with a practical project involving an automatic warehousing system controlled using the SFC programming language. The system automatically fills racks, and the controller repeats this process until there is no empty racks. In video tutorial lesson number 31, we examine human-machine interfaces or HMIs. This tutorial introduces the essential ideas of HMIs, highlighting their role in connecting operators and industrial control systems. The tutorial presents 2 HMI implementation methods. Initially, it shows how to create an HMI screen using Factory Talk View software, illustrating the connection of screen elements to PLC tags. This facilitates interaction with digital outputs and in numeric data. Next, it guides users in connecting an external HMI device to a PLC by USB and serial cables, stressing the importance of defining connections and importing PLC tags. The video concludes by showcasing practical HMI applications, highlighting their fundamental role in industrial automation. In video tutorial lesson number 32, the focus shifts to a more complex project involving two separate systems with factory I/O. The first system handles the movement of boxes from a conveyor to pallet and further onto stacker cranes. Meanwhile, a second independent system manages a water tank. Both systems are regulated by a PLC program. The tutorial highlights the significance of human-machine interfaces, HMIs, showcasing HMI screens designed to facilitate the monitoring and control of these systems. The HMI screen for the stacker crane system highlights the current step and status of positions, simplifying operator interaction. Effective push button on the HMI allow for pausing and resuming of processes. The HMI further shows control over the water tank system through a slider, controlling water level efficiently. The program structure in RS-Logix 5000 is explained, highlighting the interaction between HMI screens and the PLC program. The video concludes with a comprehensive overview of HMI capabilities, enhancing the accessibility of complex industrial processes. Conclusion: unlock your PLC mastery with our comprehensive training course. Have you ever heard the wisdom of Confucius? I hear and I forget. I see and I remember. I do and I understand. We have taken this ancient insight to heart and designed a PLC training course that will not only teach you but ensure you understand every aspect of Siemens PLC programming and HMI interfacing. Introducing our Programming S7-1200 PLC and KTP400 HMI with Siemens TIA Portal and Factory I/O course is a journey of 32 high-quality video tutorials that extends over an exciting 9 hours. Our mission is simple. We want to ensure you with the knowledge and the skills needed to excel in the world of industrial automation. Here's what you can expect from our course. 1. Learning by doing. With a step-by-step guidance and hands-on showcases, you won't just watch. You will actively participate in creating PLC control programs using TIA Portal and Factory I/O. We firmly believe that the best way to learn is by doing. 2. Ladder logic expertise. We teach programming in ladder logic with a touch of functional block diagram, ensuring you're knowledgeable in the most widely used PLC programming languages. Number 3. Real-world HMI integration. Explore the continuous integration of Siemens S7-1200 PLC with an HMI for monitoring and controlling critical parameters. This practical experience is invaluable in real-world industrial applications. 4. Fundamentals and exceeding. Our course covers the fundamental commands of PLC, laying a solid foundation for you to build upon. Once you have mastered the basics, you will be ready to explore more advanced instructions and interfacing with IO-Link technology. 5. Ongoing support. When you purchase our course, you are not just receiving videos. You'll gain access to 32 high-quality tutorial videos, all the codes generated in each lesson, and the opportunity to ask questions whenever you need clarification. We are here for you through our dedicated WhatsApp channel and PLC Goods email address. Who should purchase this course? Engineering students, working engineers, maintenance, productions, or supervisors, industrialists. This course isn't just about videos. It's about empowering you with the knowledge and the skills to install and program Siemens PLCs and HMIs in your projects. Don't miss this opportunity to become an industrial automation expert. Invest in your future today and take your first step towards mastering PLC programming and HMI integration with our programming S7-1200 PLC and KTP 400 HMI with Siemens, TIA, Portal, and Factory I/O course. See you in our course.